Alright, let's go and take a look at the warm-up that you've been working on. Now, this first part I know we've rehearsed over and over and over again, but it's always good to kind of recap this. So, 6 ways to prove a quadrilateral is a parallelogram. What's one of our ways to prove it is a parallelogram? We've got 6, so give me one. Anyone? George.
Oh, pairs of opposite sides are congruent.
Good. Opposite sides congruent. What else do we have? Vincent? Good. One set is both parallel and congruent. So both sets of sides are congruent, or both sets of opposite sides are congruent. One set is parallel and congruent. Ginger?
Consecutive angles are supplementary.
Good. Consecutive angles are supplementary, and make sure we check both ways. Let's go Alan and then Assam. Good. Both sets of opposite angles are congruent. Diagonals bisect each other. And what's our last one? No? Yeah, going back to the definition. Good. Opposite sides are parallel. Okay, so let me just go ahead and pull that up so you can see it. Let's make sure you did it right. So again, both sets of opposite sides parallel. Both sets of opposite sides congruent. Both sets of opposite angles congruent. Consecutive angles supplementary both ways. Diagonals bisect each other. And one set of opposite sides both congruent and parallel. Alright, let's see how we did on this next part. Whoa, that was really cool. Sorry. So the quadrilaterals that hold the following property. Diagonals are congruent. So we've got rectangles, which automatically also means squares. And then since it says quadrilaterals, we have to also consider trapezoids and heights. So we have isosceles trapezoid for that. Anyone remember to catch isosceles trapezoid for that one? Very good. Very good. Okay, opposite angles are congruent. It's going to be all of our parallelograms. So parallelograms, rectangles, rhombuses, squares. Notice that we cannot have heights or trapezoids because only parallelograms. Not only parallelograms, but parallelograms have that, and trapezoids and heights are not parallelograms. Alright, diagonals bisect the vertex angles. Again, vertex angles we're talking about in our kites. The vertex angles are those angles made up from those triangles, the isosceles triangles. Alright, questions on A through C?
Wouldn't C also be
You know, since it's talking about vertex angles, that's what clues in the kites. But you're correct that a rhombus, it does bisect the angles. So you're right with your thinking with that. The reason why I said kites here is just simply because it's specified vertex angles. Good point. Other questions on A through C? Good. All right. So D, opposite sides are congruent. Again, that's going to be all of our parallelograms, and we again cannot have our kites nor our what's the other one? Trapezoids. Okay, E. Only one pair of sides are parallel. Did you guys have only written on your paper? I apologize. That was supposed to say only. So only one pair of sides are parallel is going to be just our trapezoids, and thus isosceles trapezoids as well. Otherwise, it would be parallelogram. Okay. Diagonals are perpendicular. So we've got rhombuses, which also means squares. But then don't forget that kites also have diagonals perpendicular. And then our last one, only one adjacent side is congruent, the other adjacent side is not congruent. That's our kites. So again, adjacent side being the sides next to it. Questions on D through G? Okay, and again, I like what Ginger said for C, diagonals bisect the vertex angles. Again, we know rhombuses are going to bisect those angles, so I like that as well. Okay. I think we did these always, sometimes never questions a previous day, but it's always good to look at it now. I think I made you guys go through and do these. So, squares are rectangles, always. Rectangles are squares sometimes. Parallelograms are never trapezoids. Parallelograms are sometimes squares. Squares are always rhombuses. Rectangles are sometimes rhombuses. When is a rectangle a rhombus? Yeah, when it's a square again. And the base angles of an isosceles trapezoid are congruent, always. So I kind of just drew this chart over here to the side. This is all of our quadrilaterals that we have here. Then we have the category parallelograms, which includes rectangles and rhombuses. And we know that if it's both a rectangle and a rhombus, then it's a square. We have our trapezoids, and thus our sausage trapezoids, and we have our kites. So that kind of helps out in figuring out this chart here. Or sorry, these questions here. Squares are rhombi. Well, I look, and squares are completely contained inside my rhombuses, so that would be O's. Rectangles are rhombi. Some of those rectangles are in the rhombuses. That's how we have sometimes there. So that helps you out to draw the chart. Alright. Interior angle of a convex polygon, the sum of them would be 180 times n minus 2. If I wanted to find just one of them, I would take that and divide by n. The sum of the exterior angles is 360. Again, if I wanted to find just one, I would divide by n. That's only for regular polygons then. And the regulars both equal out of equal angular, so convert angles, convert sides. And then our formula for mid-segment, again, or median of a trapezoid. 1/2 base 1 plus base 2, or you can say base 1 plus base 2 divided by 2. Are there any questions on that part? Again, I know we did some of that before. Okay. Now let's take a look at our back side. I think I need to pull up. Alright, so it says all three polygons are regular. Find x. What did we get for number 1? What did we get for x? 72? Anyone else get 72? Awesome. Good. Thomas, how did you get 72 for that? What did you do?
I found the three angles next to x.
Good. Can I ask you, what did you get for your pentagon? That's a hexagon. What did you get for your hexagon one here?
120.
And then what did you get for your pentagon?
108.
And then our triangle there? Okay. Okay, so once you got all those, then what'd you do?
Then I subtracted everything to 60.
Good, yeah. If we think about it, all of these angles should add up to be the 360. Good. So you subtract from 360, you got some 2. Anyone do it a different way than that? Very good. Alright, so number 2, the sum of the interior angles is 18,000 degrees. How many sides does it have? What is my formula for the sum of the interior angles again? Good. So 180 times n minus 2 gives me the total sum, and they told us that the total sum was 18,000. Alright. And then it says how many sides does it have? So what am I solving for there? N, yeah. So I'm solving for n here. Now you can distribute your 180, or you can go ahead and divide by your 180. And then you have to add the 2 over. Now I would probably divide by the 180, because then we have 1800 divided by 18. What does that give me? What was that? 100. Good. Notice that it's just 18 and 2 zeros, so times 100. Good. So then what do we get for n? Good. 102 sides. They'll probably start to look pretty close to a circle. Good. Alright, and then number 3, one interior angle of a regular polygon is 174. How many sides does it have? Alright, what did we get for our answer here? What was our number of sides? 16. Anyone else get 16? Oh, sorry, 60. Did anyone else get 60? Good. Okay. Now, there are a couple of ways to go about this. Who can volunteer one of their ways that they did this? What did you do? Okay.
I went for the amount of exterior angles.
Good. So how did you go about that? So Vincent said, hey, I'm going to do it with my exterior angles. So what did you do?
180 minus 74 for 2 angles.
So he said, okay, I know that my exterior angle is supplementary. So 180 minus 174 gives me 6 degrees, so this is one exterior angle. And then what did you do with that?
360 divided by 6.
Good. So we know 360 divided by the number of sides will give me that single exterior angle. So if we cross multiply, we get 6n equals 360. So then n is 360 over 6, which is 60. Good. Anyone do it another way? What'd you do?
I took the interior angle formula, or some of the interior angle formula, and I did it divided by diagonal.
Good. So this is our other way, is using our interior angles. We know the sum of our interior angles divided by the number of sides will give me my single interior angle. And then you can cross multiply from there. And solve, and you'll end up getting the same thing. Very good. Questions with that? Raise your hand if you did the exterior angle way. Just a couple. Raise your hand if you did the interior angle way. Okay, good. Again, either way is perfectly fine. Does not matter which way you use. All right, any questions with our warm-up? Okay. So next, what I have here for you is called a quadrilateral comparison chart. This is just a couple of graphic organizers to help you organize all of your properties of our shapes we've learned. And again, you must know your properties to be successful for this test. Okay, so this is kind of a nice place where all the properties are together, but make sure you know these properties. If you don't know that the diagonals of a rectangle are congruent, then you're not going to be able to solve certain problems that give you the measures of the diagonals of the rectangle. Likewise with your isosceles fractions. So make sure you know these properties. Let's see if I can pull it up here for you. Alright, so on this side we have this chart that says quadrilateral comparison chart. And again, it has the different shapes listed at the top and then properties listed down. You'll notice that these are parallelograms and not parallelograms. So you're just going to put a check mark or an X in the box that applies to it. Now, this next piece here, this flow chart, this is just a spot for you to list the different properties for each of the shapes there. So just kind of another way of organizing it. And then if you flip it over to the back side, on the back side here, again, it's just another chart, kind of like a Venn diagram, that lists the different types of shapes we have, as well as their properties. Okay, so what I want you to work on right now is just simply this comparison chart. Because you already have the properties listed, and you can do that on your own to help you prepare for studying for the test. But for right now, I just want you to work with your shoulder partner, or you can do it on your own, filling in this chart here, the quadrilateral comparison chart. So put a check mark or X or something in the box for each property that the quadrilateral has. Alright, I want you to go and pause even if you haven't finished this part yet. And I want you to check with your shoulder partner, compare where you put your checks or your X's and see if you got the same thing. And then I'll give you a little bit more time to finish out and then we'll go over it together. So again, just focusing on this chart here. Again, this is just a flow chart you can fill out on your own, listing the properties. And this is just a nice diagram for you, listing your properties kind of in Venn diagram shape. So right now we're just focusing on this chart here. Compare with your shoulder partners, see if you guys got the same thing, discuss if you got something different. x then 6 this is the same so now that you know, so you hear that one, it's this one. That's what it is. Alright, take another minute to finish out your properties and compare with your shoulder partner. And then we'll go over it in just a moment. Alright, so let's see how we did on this. Alright, diagonals bisect each other. What does that apply to? Diagonals bisect each other. Yeah. All parallelograms, right? So if it's parallelograms, then it's also true for rectangles, squares, and rhombuses. Very good. Anything else for diagonals bisect each other? Nope. And in a kite, we know one diagonal gets bisected, but the other one does not. So we can't do it there. All right. Opposite sides congruent. What is that true for? Julie, what'd you get for that one? Opposite sides congruent. Yeah. Again, it's a property of parallelogram, so it's going to also be a rectangle, square. Alright, and once again, kites, we have consecutive sides are congruent, 2 sets of consecutive sides, but no opposite angles, or no opposite sides congruent. And for a trapezoid, we have our legs are congruent, but not the bases, so those weren't candidates yet. Alright, diagonals are perpendicular. What is that true for? Diagonals perpendicular. New, what'd you get for that one? Diagonals perpendicular. Beautiful. So if it's a rhombus, it also must be a square. If it's a property rhombus, it must also be a property square. And then also kites. Very good. Very good. All right. Anything else for diagonals perpendicular? Okay. All right. Opposite sides parallel. What is that going to be true for? Anyone? Vincent?
Rhombi, squares, parallelograms, and rectangles.
Good. Rhombuses, squares, parallelograms, and rectangles. Once again, that's a property of a parallelogram, so it's going to be all of our parallelograms. So I'm actually just going to go ahead and put a star or kind of a highlighted dot next to the ones that are properties of parallelograms. We have diagonals bisect each other, opposite sides congruent, opposite sides parallel. What other properties here are properties of parallelograms? Thomas, you sound like you really want to tell us. What is another property of parallelogram? Good. Consecutive angles are supplementary. And Georgia, what else?
Opposite angles are congruent.
Good. Opposite angles are congruent. So if that is true, then we automatically know for each of these that we're going to have all of our parallelograms. So opposite angles congruent. I know that I'm going to have that for all of my parallelograms. Now let's just double check. Do I have opposite angles congruent for kites or trapezoids? No. For a kite, just one set, and trapezoid, opposite angles can't be congruent. And so again, for consecutive angle supplementary, since that's parallelograms, I have that true for all of my parallelograms. Consecutive angle supplementary, do I have that for kite or trapezoid? No. Alright. So again, recognizing those properties of parallelograms makes it a little bit easier to learn. Okay, let's head back. Diagonals are congruent. What is this particular to? Alan, what do you think for this one? Diagonals are congruent.
Square and rectangle.
Good. Diagonals are congruent for a rectangle, which means it's also a property for a square. Anything else for diagonals congruent? No? Good. Don't forget that diagonals are congruent in an isosceles trapezoid. So I'm going to specify that's for isosceles trapezoids. Go ahead and make that mark on your chart as well. It's not true for all trapezoids, but for isosceles. Good. All right. For congruent sides, what meets that requirement? Matthew, what do you think of that? For congruent sides.
Rhombus and square.
Good. Again, if it's a property of a rhombus, then it must be a property of a square. Good. Anything else that has four congruent sides? Good. All right. One pair of opposite sides parallel. And again, we're talking about only one pair here. So we kind of talked about this already. But if I have only one pair of opposite sides parallel, what would that be? Good, trapezoid. I cannot say parallelogram because parallelogram has all of them. In height, we don't have opposite sides parallel. Alright, for congruent angles. What gives me four congruent angles? Which shapes have that property? Laura, what do you think? Four congruent angles. Good. It's a property of rectangle, and thus it must be a property of our squares. Alright, any other shapes for that one? Good. Alright, diagonals bisect the opposite angles. Which shape is that true for? Diagonals bisect opposite angles. Who remembers this one? Samantha, what do you think? Good. Diagonals bisect opposite angles guarantees rhombus, which means if it's a property of a rhombus, it must also be a property of a square. Now for kite, I'm going to say be careful here. It bisects the vertex angles, but not the other ones. So if you want to write in vertex only, that would be fine. But we don't have that it bisects both its opposite angles. Alright, so that leaves us with two pairs of consecutive sides congruent. Two pairs of consecutive sides congruent. What is that true for? Anthony? A height. Very good. That's true for a height. Two pairs of consecutive sides congruent. Now, technically, is that also true for a rhombus? Are my consecutive sides congruent on a rhombus? Yeah, because all of them, right? So technically, we also have it's true for a rhombus, and then that means what else? Square. Okay. So notice that square has the same properties as any of our rhombuses or rectangles. So you'll notice that square has the most full. All right. Show me thumbs up, thumbs up, thumbs down. How you do with this chart overall? Very good. So again, you need to know your properties. That is a non-negotiable. You must know your properties. If I were to give you a blank chart like this on the test, you should be able to fill it in perfectly. Okay. Any questions on this part? Yes, Vincent. Yeah. So on a kite, we know that we have two sets of consecutive sides congruent, right? So what you want to think of is, where are my isosceles triangles? So my isosceles triangles would be where those two congruent sides meet up. So this is one vertex angle, that's what gets cut in half, and this is another vertex angle, and that gets cut in half. And then it's my non-vertex angles that are congruent. So what I can say is that this whole thing is congruent to this thing. Whereas these pieces are congruent and these pieces are congruent. But we don't have that they're congruent to each other, otherwise it would be a curved thing. Does that make sense? So vertex angles come from the congruent pieces meeting up. Other questions with that? Alright. I want you guys to try this next problem. You can do this anywhere that you have extra space, perhaps on the back of that warm-up. I want you to work with your shoulder partner on this next problem. Alright, so next we're going to take a look at our fate quiz. And again, this is just extra practice quiz we used to use in years past. Deals more so with kind of the trapezoids and kites. And then on the back side, let's see if it shows it here. There's just some more dealing with properties. So list the quadrilaterals that have the following properties, true and false. So just some more practice with those properties. So while I'm passing back your quizzes, I want you to go ahead and work on this with your shoulder partner or on your own. The key for this is posted on Blackboard. Again, it's just extra practice for you to kind of prepare for our test next class. Alright, so again, this just has more practice. You can work on either the front side or the back side by yourself or with the shoulder partner. Alright, also I wanted to bring to your attention, so on Blackboard there's some extra review beyond what we have done and are doing today, if you want that to study from. So on Blackboard, under course materials where everything is, so you can see what I'm seeing here. So down here in our Unit 6 folder, we have what we are doing today with our review. But there's also extra practice. There's just a lot more practice with another review packet, more review with trapezoids and kites, just a lot more there. I recommend as you're studying, preparing for the test, again, that you look over your quizzes, see what mistakes you made to not make those same mistakes, and make sure you know those properties, because if you don't know your properties, you cannot be successful. But there are keys for everything we did today, as well as some extra stuff if you want that to review. So again, go and work on that fate quiz, and I'll get you back your guys' quizzes. is there anyone that did not get their quiz back? So again, we've gone over it. If you did not do well on it, do not be discouraged. This is the very beginning of the quarter. There's only going to be 2 grades in the grade book. So use this to study from and use it as a tool to do better on your test. Remember, your test holds more weight, and we will have an extra credit opportunity towards the quiz category like always. So don't let this discourage you. It's one of many grades. Use it as an opportunity to study from and prepare better for the test. Again, make sure you know those properties to be successful and read carefully to work. Okay, just real quick on this fake quiz here. Again, the answer key for this is posted up on Blackboard. So here they give us, it's an isosceles trapezoid, and they tell us something about DN and CN. Keep in mind, our diagonals of an isosceles trapezoid are congruent. So again, you need to know those properties to know that we would set those two equations. And then also we have that the same side angles are going to be supplementary, base angles are going to be congruent. Now for number 3 here, they tell us information about our kite here. So we have, again, that these are perpendicular. So we have each of those are right triangles. So you can probably use the Pythagorean theorem to help you out with finding some of those unknown sides. Also, we know that in a kite, so if our diagonal got bisected, and then our other diagonal is going to bisect those vertex angles, so those will be congruent. Those will be congruent. So you can use that information. And then again, on the back side, we have some more information properties. All of that is up. I'm going to go pass out your review packet to you. Again, the answer key is posted up on Blackboard. Make sure you come see me with any questions before next class. The next class is our test.